This video is for Chapter 4, Lesson 5, Compare Properties of Functions. What will we learn today? To compare two functions represented in different forms. Example number 1. A zebra's main predator is a lion. Lion can run at a speed of 53 feet per second over short distances. The graph on the right shows the speed of a zebra compared to their speeds. So let's look at some information here. To compare their speeds, compare the rates of change. A lion can travel at a rate of 53 feet per second. We're told that right there. Third thing we do is to find the rate of change for a zebra, choose 2 points on the line and find the rate of change between the two of them. So we're going to find the rate of change of the zebra. So pick 2 points. They picked 118 or 118 and 159. And the change in distance, 118 minus 59, which is 59. And then 2 minus 1, which is 1. And that gives us the information of a zebra can travel at a rate of 59 feet per second. And since 59 is greater than 53, the speed of the zebra is greater than the speed of the lion. So as long as you wrote it like this, make sure that you represent 59 represents the zebra, 53 represents the lion, you would be okay. Example number 2. The function m is equal to 140 times h, where m is the miles traveled in h hours, represents the speed of the first Japanese high-speed train. The speed of a high-speed train operated in China and today in China is shown in the table. Assume the relationship between the two quantities is linear. So step A says to compare the functions y-intercepts and rate of change. So let's look at the Japanese high-speed train first. So let's just write Japan. And over here I'll write China. And the function for the Japanese high-speed train is m is equal to 140 times h. And obviously there's no y-intercept, which is 0. Let me just add that in there. Okay. So looking at the hours and miles for the train in China, it looks like it's going up 217 miles per hour. So the function is going to be m is equal to 217 times h, and again it hasn't moved, so that the y-intercept is going to be 0. So based on the rate of change, you can see that the China train is greater, or the speed is greater than the Japanese train. You write that. Part B, they say if you ride each train for 5 hours, how far will you travel on each? So I'm going to take 5. So h is going to be equal to 5 for each of the functions. So let's start with Japan. So for Japan, we will have m is equal to 140 times 5. And I'm not going to worry about the plus the y-intercept of 0. So 140 times 5 is 700. So for Japan, it will be 700 miles traveled. Let's try China. For China, it's m is equal to 217 times 5. That's going to equal 1,085 miles traveled for the Chinese train. Make sure I put my square on my answers. And let's not forget where we compared them. There you go. Example 3, financial literacy. Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill is represented by the function y is equal to 0.15 or 15 cents times x plus 49, where x represents the number of minutes and y represents the cost. Benjamin's monthly cost is shown in the graph. So we're being told to compare on step A, compare the y-intercepts and rates of change. So it looks like we're going to be comparing minutes. Which one, which plan, or whose phone bill is cheaper? So comparing y-intercepts, so let's look at Angela first, because that's been given to us already. The cost is 15 cents per minute plus 49. Now for Benjamin, we're going to have to look at the graph, and the y is going to be the same. The total cost is equal to, before we can figure out the minutes, I'm going to see where the starting cost is. And so he has a starting cost of $60. So that's going to be our y-intercept. So in our y-intercept, we can see that Benjamin's plan is higher. It has a higher starting cost or initial cost. But let's look at what the monthly rate is. So what I'm going to do is I'm going to take my 2 points. It's going to be 0.1 and 0.2. And I'm going to find the rate of change. I'm going to take, let's see, my x, my y2 minus y1 over 120 minus, 0. And pretty much we're looking at our slope-intercept form or formula. So 72 minus 60 is equal to, I'll do it down here, 12, and 120 minus 0 we know is 120. We want to divide this because we're trying to find the rate. So 12 minutes divided by 120 looks like it's going to be 0.1 or 10 cents per minute. So I'll take that 10 cents, plug it in here, times x. So it looks like Benjamin's plan is cheaper per the minute. So by minute, so Benjamin pays a higher initial cost but pays less per minute. That's one possible answer. What will the monthly cost be for Angela and Benjamin for 200 minutes? Let me separate this here. So at 200 minutes, I'm going to take first Angela, and I'm going to take y is equal to 0.15 times 200 plus 49. And I'm going to write the same thing for, I'm going to do a different column for Benjamin. Right, we'll say Ben. That's going to be y is equal to 0.10 times 200 plus 60. Ran out of room. So I'm going to take my calculator, 0.15 times 200, which is 30. 30 plus 49. So for 200 minutes, the cost for Angela is $79. Let's look at Benjamin. I'm going to take 0.10 or 0.1 times 200, which should be 20, plus 60. Y will equal $80. So what this is telling us, let me make sure I box these answers up. What this is telling us is that if both of them are going to only use their cell phone for 200 minutes, it is $1 cheaper to use Angela's plan than it is to use Ben's plan, because there's a difference of $1 between the two plans. Real world example. Example number 4. Financial literacy. Lorena's mother needs to rent a truck to move some furniture. The cost to rent a truck from 2 different companies is shown in the table and the graph. Which company should she use to rent the truck for 40 miles? Okay, so we have Crosstown Movers, we'll call that company A, and Ron's Rentals, we'll call that company B. So let's start with A, Crosstown Movers. So we have a total cost, which is going to be my Y, and I'm going to have a constant rate of change, let me look at my constant rate of change. So it looks like for 10 miles, it's $35. For 30 miles, it's 45. So let's use our slope formula. So I'm going to take 45, so y2 minus y1, 35, and x2 minus x1, 10. So we have 45 minus 35, which is 10. 30 minus 10, which is 20. We know that that's 1/2, so we can say it's 50 cents per mile. So let's go 50 cents times x is going to equal, or sorry, not equal. We need to add our initial cost. So she has to pay $30 just to use that truck. Let's look at company B, or Ron's Rentals B. And we're going to use a table here. We're going to find the constant rate of change. We're going up by 10. Up by 10. So adding 10. And over here we have 25 plus 50. Or 250 plus 25 plus 25. So here we're going to use our y over x. So our y is 25 and our x is 10. This simplifies. 25 divided by 10 is 2.5. Or it looks like our total cost is going to equal $2.50 per mile. Okay, that makes sense because 2.5 times 10, 25. 2.5 times 20, 50. And 2.5 times 30 is 75. So she wants to use it for 40 miles. So let's plug in 40 to both of them. Let's start off with company A. Y is equal to 0.5 times 40 and add the 30 cents. $30. So half of 40 is 20. So 20 plus 30, y would equal 50. So the total cost would be 50 for crosstown movers. Now let's try y is equal to 2.5 times 40. And 40 times 2.5 is $100. So going back to the question, which company should she use to rent the truck for 40 miles? As you can see, y is equal to 50 for crosstown movers. So we will say, let me write her name, and let's use a different color. Lorena should use crosstown movers. There you have it. For today's Ticket Out the Door, please make sure to click here and enter the code GMQF339, informative to answer today's Ticket Out the Door.